Hello everyone, very good evening and welcome to the BYJU'S exam prep, the most comprehensive app for all competitive exams. Now, in this session, we will discuss first order transient with RC circuit. Okay, as you know, capacitor is a very important element, and this topic from circuit theory or network, again, it is important for all competitive exams. But before starting the session, let me know that sound quality, picture quality, everything is fine. And remember guys, transient first order RC circuit. Okay, once you will get the command over this topic, you will be able to solve the questions from network, that is circuit theory, and you will be able to solve the questions from what? Analog, right? Already I have given you idea that number of circuit based on RC, that is what? Monostable multivibrator, astable multivibrator, triangular wave generator, square wave generator, right? That is based on simple first order RC circuit. Okay, so just I am going to start my session guys, and if stay tuned with me if you want to get the command over this topic. Very simple RC circuit. We will discuss two RC circuit. One is what? Source free RC circuit, and second one is what? RC circuit with source. We will solve some examples also so that you will get the idea, and in next class we will discuss number of questions on RC circuit. I think now you are ready. AK creation. Very good evening. So this is a transient first order network. Then this is my introduction. Myself Sanjay Rathi. I am having 22 years of teaching experience, and I have trained more than 1 lakh students for these competitive exams. And I have qualified and selected for engineering services exam that is conducted by UPSC. These are my ranks: AIR 16 in ESE 2005, AIR 21 in ESE 2008. Okay, and in every time, every exam, RC circuit. In interview, again RC circuit. If you want to design the high pass filter, low pass filter, again RC circuit. And mostly question on first order RC circuit. Okay, this is a very important opportunity for you. Take a step towards success in GATE, National Scholarship Test for GATE exam. Get up to 90% off on our program. And what is the date? 28th May, means this Sunday at 12 p.m. You can register now. And guys, it is a very golden opportunity for you. Try to give this scholarship test on this Sunday. Okay. Then tomorrow I am going to take very important session. Right now, it is time to start preparation for GATE 2024. But is there any foolproof plan so that I am going to get what? Single digit rank or top rank? Yes. Now tomorrow at 8 p.m. that is on Saturday, I am going to explain that is what is the 50 plus 20 plus 10 plus 5 formula for GATE 2024. Right? And what is the meaning of this, and what is the meaning of this curve? That is the linear curve, and this is a non-linear curve. So actually in our life, what about our preparation? What about our height? Everything on practical ground follow non-linear curve. Then how we can use this for our preparation? So within 20 to 30 minutes, you will get the idea. Tomorrow at 8 p.m. sharp, to subscribe our channel so that you will get the notification about this session. Okay. Okay, then capacitor. What is the nature of capacitor? In my first class, I have given you the idea. Capacitor does not allow sudden change of voltage. And what is the reason? Because when it will allow the sudden change of voltage, then current will be infinite. That is practically not possible. So VC0 negative before switching and after switching, the voltage across the capacitor will remain same, and that is called what? Initial condition, guys. So because the capacitor does not allow sudden change of voltage, then when we are applying the voltage like what? Step signal, definitely there will be transient, and after some time circuit will reach to what? Steady state, and that is the nature of what? Capacitor. So why we are getting the transient? Because of switching action. Suddenly we are applying any voltage, suddenly we are disconnecting any voltage, suddenly we are connecting any extra element in a particular circuit, then definitely circuit will show transient, and after some time will reach to what? steady state, and that is because of nature of capacitor. Now, the current in a capacitor is zero if the voltage across it is a constant. That means capacitor acts as an open circuit to DC. We are saying that capacitor acts as open circuit for DC, but under steady state. This is called steady state condition. This is the steady state condition. Guys, now we are going to discuss 2 points. What is the transient and what is the steady state related to RC circuit. ठीक है, एक एक क्रिएशन. तो आज हम लोग डिस्कस करेंगे RC circuit. Then what is the transient response? Right, what is the transient? When we are suddenly changing the input signal, or when we are disconnecting any element from the circuit, or we are connecting extra element in the circuit, right, then transient will occur, but it is temporary part. After some time it will die out and circuit will reach to what? Steady state. And remember, the steady state is permanent part. Okay, so transient, and that depends upon the nature of the circuit. Okay, so that is called what? Natural response. What is the transient is also called natural response. किसी सर्किट का रेजिस्टेंस ज्यादा है तो उसको रजिस्ट करेगा, तो उसको ज्यादा टाइम लगेगा सेटल होने में. किसी सर्किट का रेजिस्टेंस कम है तो वो कम रजिस्ट करेगा, तो वो जल्दी सेटल्ड हो जाएगा. राइट, तो इट डिपेंड्स अपॉन द वैल्यू ऑफ द एलिमेंट्स, इट डिपेंड्स अपॉन द नंबर ऑफ कंपोनेंट्स इन अ पर्टिकुलर सर्किट. तो ट्रांजिएंट, that is what natural response. It depends upon the nature of particular circuit. It depends upon the time. It is a function of what? Time. But steady state is independent of time. So under once you will reach to what? Steady state, circuit the response will be stable. Okay, so that is the transient response in the circuit's temporary response that will die out with time. Transient reason where the signals are highly dependent on time. There is no voltage or current sources. This response is also called as natural response. Transient solution is the solution of the homogeneous equation, so only complementary function exists. What is the meaning of the last point? When we are having the differential equations, there are two types of differential equation: homogeneous differential equation and non-homogeneous differential equation. So what is the transient? Transient is the solution of homogeneous differential equation. Complementary function, I am using the terms from mathematics. Complementary function, I will discuss all these points in this session with important examples. Okay, stay tuned with me. Okay then, so this is the complementary function. Now steady state response, already I have given, it is a permanent response of the circuit by applying the external excitation signals, or if it is a, if I am giving sinusoidal signal, sinusoidal, so periodic signal, then output will be periodic, but it is stable, right? It will give the same response. Okay, then third important thing, it is called force response. Force response, why? Because when we are giving the input, output will give the response according to the input, and that is called what? Forced response. So transient is called natural response, steady state response is called forced response. Transient is complementary function, steady state is what? Particular integral. When we are having the non-homogeneous differential equation, we are getting two solutions: complementary function and what? Particular integral. Steady state response represented by particular integral. We will solve this then. So it is due to applied source. Now guys, complete response of any circuit. When we are getting some numericals in what? GATE exam or any competitive exams, sometimes we have to find the complete response of the circuit. Then we have to calculate the initial condition, what is the source applied there, then what is the transient response, what is the steady state response. Then when we are adding all the response, then we are getting the complete response. So what is the complete response? Transient plus steady state response is called complete response. My gate, so what I can do, start my preparation. Jagdish, if you are not able to start your preparation, tomorrow I have one session for you, sharp at 8 p.m. Okay, please join that session on the same channel, and I will give you the idea. I will discuss the 50 plus 20 plus 10 plus 5 formula, and in the month of June, July, August, September, if you are going to follow that formula, definitely you are going to get the good rank in GATE exam. Tomorrow at 8 p.m. Okay. Okay. Oh, it's up to you. AK creation, it depends upon the person. Okay. I'm not asking to take something else, but just follow the instructions. Start your preparation as early as possible. Then there are two types of circuit. When we are talking about the transient, as you know, in syllabus, two types of transient in syllabus. First order circuit or what? Second order circuit. First order circuit means simple RC circuit or RL circuit. For example, this is the RC circuit or this is what? RL circuit. So we are having one reactive element and we are getting first order differential equation. So this type of circuits are called first order circuit and we are getting first order differential equation. Today I will solve this circuit and tomorrow in next session we will solve question on this, question on RC circuit. Then next we will discuss RL circuit because these two circuits are very, very important one. For electronics student, normally questions on RC circuit. For electrical students, normally questions on what? RL circuit. But both are important. RC or RL, first order circuit. What is the second order? When we are getting the second order differential equation, or effectively there are two reactive elements in the circuit. Two reactive element means, just I am going to give you the example of the second order circuit, then we will solve. Any idea about the second order circuit, guys? Yes, please. Now, second order circuit means, for example, in any circuit, inductor is present, capacitor is present, both. This is called second order circuit. RLC, here we are giving the source. Or what? In parallel that is connected. RLC, this is called series RLC circuit and parallel RLC circuit. But there are some other examples, here we are having the capacitor, this is resistor, again we are having the capacitor, this is resistor. Again this is a second order circuit because we can't calculate the C equivalent. This is a second order circuit, two effective reactive element. Similarly, if you are having this type of circuit, this is called what? Second order circuit. This is called second order circuit because we can't calculate the C equivalent directly. So this is the second order, that is the second order, all are second order circuit. But if this is the case, we are having the two capacitor in parallel. In what is the difference? Here we can't calculate the C equivalent and that's why it is the second order. But here we can calculate the C equivalent. What is the C equivalent? C1 plus C2 directly. Now it is not a second order circuit, actually it is a first order circuit. Only we have single capacitance. This is the first order circuit. So we have to solve the questions on both the circuit, but today I am discussing only RC circuit. Now I think you are ready, everyone. Okay. Now, why we are getting the transient? That is because of nature of what? Elements, inductor and what? Capacitor. Okay. Normally we are not getting the questions on that AC transient, nor questions. It is not mentioned actually. Transient only mentioned. We are getting the 90% question on DC transient. But it is, yes, King, it is not very tough to solve the questions on what? AC transient. Simple methods. Okay. But transient response will remain same whether it is a DC or AC because it is independent of applied voltage. Independent of applied voltage. Now register. Remember guys, register before switching, that is called switching. Now, the student will find difficulty what is the meaning of the switching then. Now try to understand. First of all, what is the meaning of the switching? Step signals. What is the step signal here? This is time. Now, this is 0. before 0, step signal is 0. Okay. Exactly at 0, suddenly it will rise up to what? V volt. Suddenly it will rise up to what? V volt. What is the change here? This is called sudden change. So exactly at 0, it will switch from 0 to V volt. It may be 10 volt or 20 volt. Then V. We are describing it is 0 for t less than 0. It is V for t greater than 0. So what is the value at 0? There is a sudden change, abrupt change, or what? Discontinuity. Suddenly we are changing the voltage from 0 to V. So we can't define the value exactly at what? 0. And that's why we are giving the 2 time. T equal to 0 negative. What is the value of Vi? That is 0. T equal to 0 positive. Just after the switching, Vi will switch to what? V. And this is called what? Sudden change or what? Abrupt change. Okay. Sudden change or abrupt change. Okay. If there is a sudden change in the circuit, right? There is a sudden change. If suppose we are having the resistance only. Suppose we are having the resistance only. Let's try to understand this question and give me the answer for this. For example, I am having the 5 ohm resistor here, 5 ohm resistor here, and this is the V volt. Initially nothing is applied here. Nothing is applied here, switch is open, and this is the signal here, 10 volt. Nothing is applied here. So what is the voltage? 0. But suddenly we are closing the switch. It is just like applying the step signal. When we are closing the switch, then this 10 volt is applied in the circuit, and resistor allow the sudden change of voltage as well as sudden change of current. Then what will be the output voltage? Suddenly, when the input switch, initially what was the input? 0 here. But when we are closing the switch, the input will rise to what? 10 volt. When input will rise to 10 volt, the V0 will suddenly rise to what? 5 volt. According to voltage division rule, the output will become 5 volt. And what is the voltage across this resistor? Again 5 volt. This is 5 volt, this is 5 volts. Why? Because resistor allows sudden change of what? Voltage. So suddenly the output voltage will switch to what? 5 volt. But if in place of we are connecting the capacitor, in place of this, if we are connecting the capacitor, then suddenly we are closing the switch here, right? Same thing. Now 10 volt is connected to the circuit, but this time the capacitor is connected. And before switching, what is the voltage across the capacitor? That is called VC0 negative, is 0. Initially unenergized capacitor. Unenergized capacitor means there is no energy and voltage is 0. When we are closing the switch, capacitor will not give the response, right? And what will be the voltage across the capacitor? Initial voltage, it will remain 0 just after switching. And that's why we are representing VC0 negative is equal to what? VC0 positive. It will not allow the sudden change of voltage. And if the initial voltage is 0, it will remain short circuit. It will remain short circuit. Right? So we are applying the 10 volts. The input will suddenly switch from 0 to 10 volt, but the output will not give the response exactly at 0 plus. It will remain 0. And that is called initial condition. Capacitor initially behaves like what? Short circuit, because initial voltage was 0. Now, when we are giving the time, the capacitor will charge, just like your mobile. The battery will take time now for charging. So that is called what? Charging of the capacitor. And it depends upon the value of resistor and what? Capacitor. After some time, the capacitor will fully charge up to what? 10 volt. So that is the condition, that is the story of what? Capacitor. So resistor allow the sudden change of voltage, but capacitor does not allow sudden change of voltage, and that's why we are getting transient. Now, so that is the basic. So why we are getting the transient? Simply That was the question in what competitive exams. We are just connecting a battery of 10 volt. Or suppose you are removing the battery, again there will be the transient, right? Oh, 1 minute. Again you are removing the 1 minute. Yes, that is the case. Okay, now watch this table. Initial condition, resistor will remain resistor. Inductor will behave like what? Open circuit initially, because inductor does not allow sudden change of current. So if the initial current T equal to 0 negative, if the current through the inductor is 0, then exactly at T equal to 0 positive, it behaves like open circuit, means the current will remain 0. Capacitor. If the initial voltage across the capacitor is 0, then it behaves like short circuit initially, because the voltage is again 0. Short circuit. If it behaves like short circuit means what? Voltage is 0, but it will allow the current. Current can flow. Here the current was 0, but here the current is non-zero value. It can allow the flow of current. Similarly, inductor, there is no current initially. After switching there will be no current, but it will allow the sudden change of what? Voltage. Sudden change of voltage. So inductor allows sudden change of voltage, capacitor allows sudden change of current. Okay, that is the case. Now what is the meaning of this? This is short circuit. If there is some initial current through the inductor exactly at T equal to 0 negative, like this is the current will flow exactly at T equal to 0 negative, then initially it behaves like a current source of value I. That is exactly at 0 plus. Suppose there is a current of 3 ampere initially, it does not allow sudden change of current. Exactly at T equal to 0, it will remain 3 ampere. So some students are confused. They are always saying that inductor behaves what? Open circuit. But if there is an initial current 3 ampere, then it behaves like a current source of 3 ampere. Similarly, when we are talking about the capacitor, we are saying that initially the capacitor behaves like what? Short circuit. Okay, that condition is okay. But if the VC0 negative is 0, then VC0 positive is also 0. But if we are having some initial voltage across the capacitor, for example, VC0 negative is 3 volt. Just after switching, it behaves like a battery of voltage 3 volt. Like that. This is the plus, this is the minus, and that is the value. And this is the VC0 plus. It is also 3 volt. Capacitor does not allow sudden change of voltage. Okay, so remember that. If it is unenergized, then initially it behaves like short circuit. Otherwise, it behaves like a battery of initial voltage. So that is called initial conditions. Now, this is about the inductor and capacitor. Then, already I have given why we are getting the transient. Now it is time to solve some circuit. First important circuit is what? Source free RC circuit. And second one is RC circuit with source. This is the RC circuit without source. This is the RC circuit with source. Here we are connecting the external battery, that is the VS. And I am talking about the DC transient. So it may be of 10 volt, 20 volt, 30 volt and so on. So it is called RC circuit with source, and this is called RC circuit without any source. When we are talking about the RC circuit without any source, means in a capacitor, initially capacitor is charged just like your mobile, right? We are purchasing the new mobile, initially it is charged. Now we are going to start using the mobile. Then what about the capacitor? Everyone give me the answer. Capacitor will charge or discharge? Your battery is just like what? Capacitor. Capacitor ही है, बताइए. We have purchased new mobile and just we are going to start it. Initially already it is charged. When we are using it, it will what? Discharge. Finally, we are connecting the charger. When we are connecting the charger, again the the battery will charge. And that is called, when we are connecting the charger, we are saying that RC circuit with source. When we are using the mobile without any charger, then we are saying that RC without source. There are two circuit, discharge. Okay, Salija, your answer is correct. Now, then RC circuit, I am going to explain this diagram, very, very important one. Then watch this. This is RC circuit. Source free RC circuit. There is no source. Then there is an initial voltage across the capacitor, like this is called VC0. It may be 5 volt, 10 volt, anything. We are representing like V0, like this is the initial voltage across the capacitor. Now, if you want to write equation, like this is the current I, then you can write a KVL, you can write an equation IR plus VC. What is the VC? Voltage across the capacitor is equal to 0. Directly I am writing the KVL. IR plus what? VC. So that is the KVL. Now IR plus VC. What is the current through the capacitor? If there is a current through the capacitor like this, in this direction I, it entered through the plus, leave the minus, then we can write I is equal to C dVc by dt. C dVc by dt. So just I am replacing this I by what? C dVc by dt. This is the equation number 1, this is the equation number 2, and this is the equation number 3. Then this equation will become R C dVc by dt plus Vc is equal to what? 0. Then divide it by RC, dVc by dt plus Vc by RC is equal to what? 0. We are getting the differential equation here. We are getting one differential equation here. And this is what? First order differential equation. First order differential equation for this particular circuit. Second important thing, this is a homogeneous differential equation. Okay. Now, once you will get the dVc by dt plus Vc by Rc is equal to 0, that is called homogeneous differential equation. And according to mathematics, it has only one solution, that is called what? Complementary function. Complementary function. Now I will solve with the mathematics and other methods. So dVc by dt, if you got this equation, differential equation. Now focus on the differential equation. Plus Vc by Rc is equal to what? 0. Now, and this d is called d by dt. Then I can write like this, what? D plus what? I am taking the Vc as a common. So it will become d plus 1 by Rc to Vc is equal to what? 0. And you will get d plus 1 by Rc is equal to what? 0. So what is the root here? Minus 1 by Rc. And that is the method to solve what? First order differential equation. First of all, get the root. What is the root here? Minus 1 by Rc. Then what is the solution here for the first order differential equation, homogeneous differential equation? Solution is, once you will get the root, Vc will become k. K is called constant, e raised to power mt or dt. What is the d? The root. What is the value here? Minus 1 by Rc. And that's why the solution will become Vc is equal to k times of e raised to power minus t by Rc. That is the equation. Okay, very simple. How we can find the value of the k? So exactly at t equal to 0, what is the value of the voltage? It is given in the question. V0. V0 means let maybe 10 volt, 20 volt, it is given in the question. For example, I am assuming let 10 volt it is given. Then this equation Vc is equal to what? V0, that is equal to 10 volt. Put here. This will become V0, that is equal to 10 volt, that is equal to k e raised to power 0. E raised to power 0 will become 1, and what is the value of the k? 10 volt. Now, when we are using the value of k, what is the solution here become? Vc is equal to V0, that is I am giving the constant value, e raised to power minus t by Rc, or 10 e raised to power minus t by Rc. Very, very, very simple solution. So what are the important things? First of all, write the differential equation for this circuit. Replace the I by C dVc by dt. You will get the first order differential equation, and that's why it is called first order circuit. Second, we are getting the homogeneous differential equation because there is no external source. There is no external source, homogeneous differential equation. What is the solution of the homogeneous differential equation? Get the root, and that is the general solution, and you will get this formula. And how we can find the value of k? From the initial condition, that is the general solution, 10 e raised to power minus t by rc, or v naught e raised to power minus t by rc. This is exponentially decreasing function. How we can plot it? Then remember, this is a very important diagram, guys. This is how I am going to plot it. This is the time, and that is the voltage across the capacitor. Yes. Now, the initial voltage across the capacitor is V naught, that is the 10 volt. Okay. Capacitor does not allow sudden change of voltage. So before switching, what was the voltage across the capacitor? 10 volt. And now the circuit will start. When the circuit will start, the capacitor will discharge exponentially. When the capacitor will discharge exponentially, according to this equation, that is the curve. Exponentially decreasing function. Exponentially decreasing function. Now, how we can find the different values? Then, when we are having the equation V naught, that is Vc, Vct, that is the function of time, V naught e raised to power minus t by rc. First condition, let t, we are putting the different values of t. First of all, put the value of the rc. When I am giving the value, then the Vc will become V naught e raised to power minus 1. Put the t, rc by rc, it will become minus 1. Every student, please remember this value. This will become V naught by E. And V naught by E is nothing but 0.368, nearly equal to, check my calculation. Is it the value 0.368? Yes. 368 times of V naught means initial voltage. If it is 10 volt, then it will become 3.68 volt. 3.68 volt when we are using the V naught is equal to 10 volt. Then it is in one time constant. Then when I am giving the 3 time constant, and this is called what? Time constant. In one time constant, it will reduce up to what? 36.8% of initial value. Then when I am using the 3 RC, it will become V naught e raised to power minus 3. And then you can find the value. It is nearly equal to, check this calculation, V naught. 0.05, nearly equal to 0.05 of V naught. If it is 10, then 0.05 into 10 means what? Only 0.5 volt. 0.5 volt. Then in a 4 time constant, e raised to power minus 4, it is nearly equal to 0.02 times of V naught. And it is 0.02, if the V naught is 10, it is what? 0.2 only. And finally at 5 time constant, that is the 5 RC, less than 1%, less than 1% means less than 0.0067 something, and it is less than what? Less than 0.1 volt. Or when we are putting the t equal to infinite, e raised to power minus infinite, that is nothing but 0. That is nothing but 0. So capacitor will take infinite time for complete discharging. Okay, complete discharging. But we can't wait up to what? Infinite time. So that is the curve. So in a 1 time constant, it will discharge up to 36%. That is important. Or up to infinite, that will discharge up to what? 0. But we can't wait up to infinite. And that's why in control, normally we are saying that after 4 tau, circuit will settle down, because final voltage is what? 0. So at t equal to infinite, it will be 0. So steady state will reach at what? T equal to infinite. But we can't wait up to infinite, and that's why sometimes we are choosing what? 4 tau or what? 5 tau. So up to 4 tau, it will reduce up to a 2% of the final value. So that is called settling time. Or sometimes we are choosing what? 5 tau. And it will discharge up to what? Less than 1%. Less than 1%. And that time is called what? Transient. That time is called transient. And after that, circuit enter into steady state. This is called transient. On the basis of 4 time constant, and that is what? 2% error. Because there is 2% of the initial value. So after 4 time constant, the circuit will reach to what? Steady state. Right? Now just after 10 to 20 minutes. Okay. Now, so that is the first case. So exponentially decreasing function. Now which type of questions? Now remember guys, if you have the formula, then directly you can use this formula. The diagram is given here. Then this type of questions. Example number 1. Very, very simple and similar type of question in what all competitive exams. The switch in the circuit in a figure has been closed for a long time. This switch was closed for the long time and it is opened at t equal to 0. Exactly at t equal to 0, we are opening the switch. Find the Vt for t greater than or equal to 0. We have to find the equation of the Vt. Calculate the initial energy stored in the capacitor. That is, after opening the switch, we are having the source free circuit, source free RC circuit. Right? Tomorrow we will discuss more and more question on that in next class, in Monday. Saturday, Sunday. Saturday I am having the general session 8 p.m. Stay tuned with me. I am going to give you the very important information. Then Sunday off. Monday again we will discuss question on this circuit. Now once the switch is open, what is this? Source free response. 9, 1, and that is the capacitor 20 millifarad. So this is the source free. But this time the voltage across the capacitor is not given. What is the initial voltage across the capacitor? For this circuit, we have the formula. What is the formula of E? Initial voltage e raised to power minus t by RC. R will become 9 plus 1, 10. 10 ohm and C is given as 20 millifarad. You can find the value of what? R and C. But what about the initial voltage? Right? So you have to find the initial voltage from the given condition. Switch was closed and exactly at t equal to 0 it is open. Now for this circuit, how we can find the initial voltage? Then always remember, when the switch is closed, for t less than 0, switch was closed. And for a long time it was closed. For a long time, if it was closed, then circuit will reach to what? Steady state. Once the circuit reach to steady state, that is for 20 volt, this is the DC value. For DC, capacitor act as what? Open circuit. Now this capacitor will act as open circuit. So at t equal to 0 negative, remember with previous condition, circuit is in steady state. Steady state. Under steady state, for DC, capacitor act as open circuit. Open circuit. So 0 negative. So when we are going to make the capacitor open circuit, then this is 20 volt. This is 3. This is 9. And this is 1. This is the capacitor act as open circuit. Okay, give me the answer. What is the initial voltage across the capacitor? Now open means what is the current through the 1 ohm resistor? 0. And this is the 20 volt. Simply you have to find the voltage across the 9 volt. That is nothing but VC. VC is nothing but voltage across the 9 volt battery. It is a VC 0 negative. It will become 9 divided by 3 plus 9 into 20 and you will get the 15 volt. 15 volt is the initial voltage across the capacitor. Okay. Now once you will get the 15 volt, This is called initial condition. Means always remember exactly at t equal to 0 negative means just before switching, circuit will be in steady state, and under steady state capacitor act as what? Open circuit. Now once you will get the 15 volt, then what is directly you can use this formula. So what is the for VC? VC will become 15 e raised to power minus t by RC. What is the R and C? That is the 10 for this circuit. For t greater than 0, switch was open. So remove this portion. This is called source free RC circuit. 9 plus 1, 10. So what will be the time constant? 10 ohm into 20 millifarad, 10 raised to power minus 3. That will become 200 upon 1000. That is the 0.2 second. 0.2 second upon 0.2. So that is become 10 by 2. It will become 15 e raised to power minus 5t. 15 e raised to power minus 5t volt. And that is the equation. That is the equation. If it is asked Vt for t greater than 0, that is the equation. Now what is the initial energy stored in the capacitor? Initial energy stored in the capacitor is given by half of CV square. What is the initial voltage? Half of 20 into 10 raised to power minus 3 millifarad into V square, 15 square. Then it will become, this is the 10 into 10 raised to power minus 2, it is the 10 raised to power minus 2 into 225, or it will become 2.25 joule. That is the initial energy stored in the capacitor. So that will become equation, and that is the initial energy. And exactly at t equal to infinite, what about the voltage across the capacitor will become 0, completely unenergized, right? It will dissipate the energy across the resistor. And what is the final energy across the capacitor? 0. And this was the initial energy exactly at t equal to 0. And that was the final energy. So this type of questions, very, very basic question. From the given condition, you have to find the initial voltage across the capacitor. Okay, that is the question. Now, second important circuit is what? RC circuit with source. RC circuit with source. Okay. This is the RC circuit, R and C. One source is connected here. This is the switch. When we are closing the switch, this is the R, this is the C, and this is the VS. Okay, very, very, very simple how we can solve this. When we are having the source, you can write down the KVL for this particular circuit. So give me 1 minute. What is the problem here? Okay. Then RC circuit. Okay. This is VS. If we are applying any DC source, switch is closed now. This is R, this is C. And we have to find the voltage across the capacitor. Now let this is the current I. Very, very simple equation. When I am writing the KVL, it will become minus VS plus RI plus VC. Voltage across the capacitor is equal to 0. Just I am writing the KVL. What is the current through the capacitor? C dVc by dt. This is the equation number 1. This is the equation number 2. Put 2 in 1 and make the Vs on the right hand side. This will become RC dVc by dt, just like the previous equation, plus what Vc is equal to Vs. Vs is the DC source, remember that. Just write it in the capital. Yes. Okay. Now divide it by what? RC. That is the equation. So we are getting a differential equation for this circuit. It is a non-homogeneous differential equation, guys. This is a non-homogeneous differential equation. Differential equation. If it is a non-homogeneous differential equation, means what? When we are solving it, we are having the two solutions. One is called what? Complementary function, and that is called transient part. And other one is called particular integral. Here it is called steady state part. It has the two solution, complementary part and what? Steady state part. Okay. So what is the complementary part? In a complementary part, you have to make the non-homogeneous and homogeneous differential equation. So I'm just giving you the very simple solution, and then directly you can solve any type of questions. For this, I'm getting the idea. That is what non-homogeneous differential equation. It is of first order. Then always remember, for transient, make Vs is equal to 0. So it is converted into a homogeneous differential equation. What is this? And now again d plus 1 by RC. In a previous question we have solved, d plus 1 by RC is equal to 0. D by dt is equal to d. What is the root? Minus 1 by RC. And what is the transient solution? K e raised to power dt. That is K e raised to power minus t by RC. Just like a previous explanation. That is called what? Transient part. Now, very interesting, what is the steady state part? Steady state part means what? At steady state, capacitor acts as open circuit. And then you have to find out what is the steady state voltage across the capacitor. What is the steady state voltage across the capacitor? For example, it is a Vs. And this is resistor R. And exactly at t equal to infinite, capacitor acts as open circuit. What is the voltage across the capacitor at infinite? This is nothing but steady state value. And this is nothing but applied voltage. For example, if it is 10 volt, then it will become 10 volt. Right? That is called steady state solution. Once you will got the transient part and steady state part, then what is the total solution? Complete solution. Complete solution. VCT is equal to transient part plus what? Steady state part. It will become, transient part is what? K e raised to power minus t by RC. And what is the steady state part? Vs, applied voltage. Now, is it a complete solution, guys? Is it a complete solution? Yes, it is a complete solution. But what is the value of K? What is the value of K? So first of all, get the complete solution, transient plus steady state. Then to find the value of constant K, you have to use the initial condition. Exactly at t equal to 0 plus, what is the voltage across the capacitor? There may be the two cases. First case, Vc is equal to 0. If the initial voltage across the capacitor is 0, means it is unenergized. Unenergized, then put the value here. K e raised to power 0, exactly the time is 0 plus Vs. So what is the value of the K? K will become minus Vs. K will become minus Vs. When I am putting this value, what is the solution? Vct is equal to Vs e raised to power minus t by Rc plus Vs with minus sign, because it is a minus Vs. And you will get the general solution that Vs 1 minus e raised to power minus t by R. And that is called first solution when initial voltage is 0. Initial voltage is what? 0. Initial voltage is 0. You will get this solution. Second solution. If initial voltage is not 0. Initial voltage is not 0. Let this is any initial voltage 5 volt or something else. This is the initial voltage, let this is the 5 volt. And what is the applied voltage? 10 volt. Then what will be the solution? Put here. Exactly at t equal to 0, it will become V naught. That is equal to k e raised to power 0 plus Vs. It will become 1. So what is the k is equal to? V naught minus Vs. V naught minus Vs. That is the value of the k. Put here value of the k, and then the solution will become V naught, it is the initial voltage, minus Vs e raised to power minus t by Rc plus what? Vs. Plus what? Vs. And that is the solution. That is the solution, guys. Or you can write Vs, this will become minus Vs minus V naught e raised to power minus t by Rc. Suppose if the initial voltage is, applied voltage is 10 volt, it will become 10 minus 10. What is the initial voltage? Like 5 e raised to power minus t by Rc. And this is called 10 minus what? 5 e raised to power minus t by Rc. That will become equation. If the initial voltage is 0, you can put the 0 here, and again you will get the answer for this question. Then we are having the two solutions for this question. Two solutions. What is the first solution? When the initial voltage is 0, that is the solution. When the initial voltage is non-zero, that is the solution. This is the general solution. Now, when the initial voltage is 0, what will be the plot? Finally, 2 minutes only. Exponentially charging equation. When the initial voltage is 0, it will start from the 0 because capacitor does not allow sudden change of voltage. And finally, it will reach up to what? Vs. That is the curve. Exponentially charging equation. Okay. It will start from 0. It does not allow sudden change of voltage, and that is the time. And what is the equation here? Vs is equal to 1 minus, Vc is equal to Vs 1 minus e raised to power minus t by Rc. And exactly at one time constant, put here 1, Vc will become 0.632 of the final value. 63.2% of the final value. And exactly at 4 time constant, 4 times of Rc, put here, Vc will become 0.98 times of Vs, 98% of the final value. This is the 1 time constant. And that is the 4 time constant. It will reach up to what? 98% of the final. And that is called transient is over after 4 time constant on the basis of 2% error. This is called transient period. Transient. And after that, steady state. So that is the equation. Okay, so these are the two circuits only. Or if you have any initial voltage, 5 volt, for example, I am giving the 5 volt, then this curve is important. So in a GATE exam, we are getting the question with some initial voltage. So number of students are confused with that. So don't worry. If the initial voltage is 5 volt, the final voltage will remain same 10 volt. That is the Vs. That is the Vs, that it is the 10 volt. But if the initial voltage is 5 volt, the curve will start from this. This is the 5 volt. Initial voltage is 5 volt, okay. That was the 5 volt. After it will start charging like that. And finally, it will reach up to what? 10 volt. So this type of curve we will get. This is 0 line. This is 5 volt and it will charge towards what? 10 volt. This is the curve here. This is called initial voltage, V naught. And what was the equation? Vct is equal to Vs minus V naught e raised to power minus t by Rc. What is this? Final value. What is this? Final value. What is this? Initial value. What is this? Time constant. So we have very interesting general formula for first order circuit. If you want to solve this question, if you have the idea about the final value, If you have the idea about the final value, if you have the idea about the initial value, then directly you can use this equation to solve any type of question for first order, based on first order. So V final means exactly at t equal to infinite what is the voltage. V initial means what is the initial voltage. For example, in this question, the final voltage is Vs, 10 volt. Final voltage is 10 volt. What is the initial voltage? 5 volt. What is the time constant? RC. Directly you will get this equation, 10 minus 5 e raised to power minus t by RC. Okay, and that is the equation. Directly you can find. Or sometimes in some books it is used VCT. Change the sign only. It will become V final plus V initial minus V final e raised to power minus t by R. In some textbook it is used V final minus V initial e raised to 1. Same thing. Just I am putting the minus sign here, and that you will get this answer. So this is about what RC circuit, simple source free RC circuit and RC circuit with source. And in next class, guys, ready to solve some questions, very important questions we will solve. I am giving you one assignment, that is the curve. If there is an initial voltage, then it will start from this point. That will be the equation, and then this is an assignment for you. This is a source free response. Try to solve this question, and that is from the standard textbook like what Sadiku, Alexander and Sadiku. Okay, and tomorrow we will solve more and more questions on these diagrams. Guys, this is a very important session on Saturday at 8 p.m. That is a linear curve, that is a non-linear curve, and during GATE exam, when we are taking what practical approach, it is always non-linear. So 50 plus 20 plus 10 plus 5 formula, it will help you to get the top rank in what GATE exam. So tomorrow at 8 p.m. sharp, and this is a GATE 2023. Our success saga continue. These are our results, right? Then we want more and more extraordinary results from you. And my guys, subscribe our channel, because we have number of sessions for you, that just like what GATE 2024 fundamental series from Monday to Friday, NIELIT 2023 crash course Monday, Wednesday, Friday, Sunday, ISRO series, and then what coffee with concept, learn with fun every Sunday at 7 p.m. right? And we have number of activities like what short videos, concept sessions and so on. Subscribe our channel so that you will get the notification about all this session. Okay, then thank you for attending the session. You are on BYJU'S exam prep, guys. 1 minute. So that is the case. Okay. So like the session and subscribe our channel. Okay, then thank you and good night.